Let's imagine a simple sewing needle. It's a tiny object, something you might find in a drawer, weighing only about a gram. In our everyday lives, it's harmless unless you happen to prick your finger. But what if we took this small, ordinary object and turned it into the most devastating projectile imaginable? What if we could somehow propel this needle through the vast emptiness of space and have it strike our planet Earth at the speed of light? It's a thought experiment that takes us to the very edge of physics, a scenario that seems to come straight from science fiction. The consequences, however, are grounded in very real scientific principles. The universe is full of mind-boggling concepts, and speed is one of the most fascinating. On Earth, we think of a speeding bullet or a fighter jet as fast. In space, we have asteroids and comets traveling at incredible velocities, but nothing compares to the ultimate speed limit of the cosmos, the speed of light. Traveling at approximately 299,792 kilometers per second, light moves so fast it could circle the Earth more than 7 times in a single second. Our tiny needle, if it could reach this velocity, would transform from a simple tool into an object of pure cataclysmic energy, ready to deliver a blow of cosmic proportions. The key to understanding this destructive power lies in one of the most famous equations in all of science, Albert Einstein's E equals mc squared. This equation tells us that mass and energy are two sides of the same coin. An object's energy isn't just about how fast it's moving, it's also about its mass. But as an object with mass gets closer and closer to the speed of light, its kinetic energy, the energy of motion, increases exponentially. It doesn't just get a little more powerful, it skyrockets towards infinity, packing an almost unbelievable punch for its size. So when we ask what would happen if a needle hit Earth at light speed, we are not really asking about a simple collision. We are not talking about a small object making a small hole. Instead, we are asking what happens when an almost infinite amount of energy is suddenly released at a single point on our world's surface. This isn't a story about a puncture, it's a story about annihilation. It's an event that would reshape our planet in a matter of moments, unleashing a chain reaction of destruction that would make all of human history's disasters combined feel like a gentle summer breeze. The instant our light-speed needle touches Earth's atmosphere, it would unleash a burst of energy that defies easy comparison. The kinetic energy carried by this 1-gram object would be roughly 43 trillion joules. To put that into perspective, the atomic bomb dropped on Hiroshima released an amount of energy equivalent to about 15,000 tons of TNT. Our tiny needle would deliver a blow equivalent to more than twice that of the Chicxulub asteroid, the one that wiped out the dinosaurs 66 million years ago. Imagine an explosion so vast it makes the event that ended the age of giant reptiles look small. This is not a conventional impact. The needle itself would vaporize instantly upon contact with the first molecules of air. It wouldn't even have a chance to reach the ground. Instead, it would unleash all its energy in the upper atmosphere, creating a fireball of superheated plasma that would expand outwards at incredible speed. This fireball would be brighter than the sun, vaporizing everything for hundreds of kilometers around the point of impact. Cities, mountains, and oceans would be turned into gas in less than a second. The sky itself would catch fire. The immediate shock wave from this atmospheric detonation would be catastrophic. It would travel across the globe, a wall of force flattening everything in its path. No structure built by human hands could possibly withstand it. This primary shock wave would be followed by seismic waves of unimaginable power, and the impact would ring the entire planet like a bell, triggering earthquakes of a magnitude never before recorded. And these quakes would cause volcanoes all over the world to erupt simultaneously, spewing ash and lava into the already chaotic atmosphere. In the moments following the impact, the planet would be a scene of pure hell. And the initial fireball would ignite continent-wide firestorms. The air itself would be superheated to lethal temperatures over vast regions of the globe. Any living thing on the surface of the continent facing the impact would be instantly incinerated. The oceans would boil near the impact zone, sending colossal tsunamis racing across the globe, scouring coastlines clean thousands of kilometers away. Our world, our home, would be fundamentally and irrevocably broken in a matter of minutes. The immediate destruction from the impact would just be the beginning of the end. The long-term consequences would ensure that Earth becomes a barren, uninhabitable rock. The explosion would eject a tremendous amount of vaporized rock, dust, and debris high into the atmosphere far above the clouds. This dense shroud of particles would quickly spread, wrapping the entire planet in a thick blanket of darkness. Sunlight would be completely blocked from reaching the surface, plunging the world into a perpetual twilight, a condition often called an impact winter. This global darkness would lead to a catastrophic drop in temperatures. Without the sun's warming rays, the surface of the Earth would rapidly cool, leading to a new artificial ice age. Photosynthesis would cease almost immediately, causing a total collapse of the food chain at its very foundation. Plants and plankton across the globe would die off, and with them, every animal that depends on them for food. The vibrant ecosystems of our planet, from the deepest jungles to the most abundant oceans, would wither and die in the cold and the dark. The atmosphere itself would become toxic. The incredible heat of the initial blast would cause nitrogen and oxygen in the air to combine, forming vast quantities of nitrogen oxides. When this material mixes with water in the atmosphere, it would rain down as nitric acid, creating acid rain so corrosive it would dissolve stone and poison any remaining pockets of water on the surface. The sky would not just be dark, it would be actively hostile to life, delivering a chemical assault on a world already reeling from the physical devastation of the impact. Ultimately, this single tiny needle would trigger a mass extinction event far more complete than any in Earth's history. The combination of the initial blast, the global firestorms, the crushing shock waves, the planet-wide earthquakes, the suffocating dust cloud, the freezing temperatures, and the acid rain would sterilize the planet's surface. It's possible that only the hardiest microorganisms buried deep underground or near hydrothermal vents in the ocean's abyss might survive. The complex web of life, built over billions of years, would be undone in an instant by 1 gram of matter moving at an impossible speed. After exploring such a terrifying scenario, it's important to take a step back and breathe a sigh of relief. Why? Because according to the laws of physics as we currently understand them, this event cannot happen. The very science that predicts the devastating energy release also explains why it is a practical impossibility. The universe has its own rules, and one of its most fundamental rules is a strict speed limit for any object that has mass. Nothing with mass, not a needle, not a spaceship, not even a single atom, can ever reach the speed of light. The reason for this lies once again with Einstein's theory of relativity. As an object accelerates and gets closer to the speed of light, its mass effectively increases from the perspective of an outside observer. This isn't just a mathematical trick. It means that it takes more and more energy to make it go faster. To push that object just a little bit closer to light speed requires a huge increase in energy. To actually reach the speed of light, the amount of energy required would become infinite. And since there isn't an infinite amount of energy available in the universe to push a single needle, the task is impossible. And think of it like trying to reach a finish line that constantly moves away from you the faster you run towards it. No matter how much effort you put in, you can get incredibly close. 99%, 99.9%, 99.999% of the way there, but you can never actually touch the line. This is the cosmic reality for any object with mass. Only massless particles, like photons, the particles of light itself, can travel at light speed because they don't have to fight against their own increasing mass. This is a fundamental feature of our space-time fabric. So while it is a fascinating and terrifying thought experiment, the lightspeed needle remains firmly in the realm of imagination. It's a great way to understand the immense power locked away in the relationship between mass, energy, and speed. It teaches us about the cosmic scales of energy and the profound consequences of Einstein's theories. But we can sleep soundly at night, secure in the knowledge that the laws of physics themselves act as the ultimate safeguard, preventing such a small object from ever unleashing such unthinkable destruction upon our world.